Number 4 from the 2008 Advanced Higher, partial fractions, but just 3 marks. And you probably have to go through a fair wee bit of arithmetic just to get those 3 marks, but it is simple though. Next, use it in an integral, but first of all, partial fractions. Well, what have we got? We've got 2 parts in the denominator. The first part's just a linear term, so I can write that as a over x. The next one is an irreducible quadratic. That's a positive. There's no factorisation for that using integers, so that would have to be written as bx plus c, a linear term over an irreducible quadratic. And then multiply throughout to form an identity between these 2 halves. So multiplying throughout by those parts, I'd have a, having the x already, would have to be x squared plus 5. The bx plus c, having that up already, will just be x. And the other side would be 12x squared plus 20. Then it's just a case of which techniques will I use. Well, I could use some knockout values to begin with, because I can certainly make x disappear if I make x equals 0. And it doesn't have a particularly onerous piece of arithmetic using those values. It's not as sophisticated as equating coefficients, but I'll be doing that next, but it does for this part of it. So if x equals 0, that means I've got this part will disappear and I'll be left with 5a. And if x is 0, I'll be left with 20, which means that a is equal to 4. So that'd be the first bit. Now for the next part, I'm not going to pick some other values and then start going through arithmetic. No, I'll then say, well, we'll start with the x squared term. If those 2 parts are the same, their x squareds must be the same. What have I got for x squared? I've got an a, lots of x squared here, and I've got a b, lot of x squared here, and that should come to 12x squared. Well, since a is 4, that means that, well, I'll write it in, b plus 4 is 12. That means that b must be 8. Then, to find c, now notice, c just involves c times x, so I'll use the x term. If you look at the x term on both sides, what have I got? Well, a is not involved in the x term. I've only got x squareds or constants. B is not involved in it, because I've got b times x squared. It's only c that produces it. The only x term in this time is c times x, so the c must equal the x term on that side, which is 0, and there it is. A is 4, b is 8, c is 0. So that 12x squared plus 20 over x times x squared plus 5 is equal to 4 over the x, and that just leaves the 8x over the x squared plus 5. Then the second part, hence evaluate this definite integral. Well, obviously, I'm going to insert that instead of that. So I've got the integral from 1 to 2 of 2 parts. 4 over x, which is an obvious log, plus 8x over x squared plus 5 dx, which is another log that you can do by inspection as soon as you notice that the top is related to the derivative of the denominator. The derivative of the denominator is 2x. The top is 8x. So you've got 4 times that. That means you've got 4 times the derivative of 2x over x squared plus 5. So you could just do it by inspection. So it's almost ready to go. I've written that there. Maybe I'll just write it out one more time. Now you could split it into 2 integrals, but there's not really any need to do that, because I'm not going to use different techniques from them both. They've both been done by inspection. By inspection because I recognise that as a log. By inspection because I recognise that as a log of some other function where I have its derivative. And that function I'll just write explicitly as 4 times 2x over x squared plus 5 dx. And then I can go straight in. Well, that's 4 times the derivative of log nx. I better just keep that with its wee raincoat on to keep it safe. And that is 4 times the derivative of ln x squared plus 5. They were both 4 times them, so I could put that 4 outside. Evaluated from 1 to 2. Notice I just put normal brackets around that because that can never be negative. X squared plus 5 is always positive. X could turn nasty on you, so let's just put the wee muzzler on it. So that then gives me 4 times, what have I got? ln of 2, well that's quite safe, plus ln of 4 and 5 is 9, minus, evaluated at 1, that's ln 1, that's quite safe, plus ln 1 plus 5 is 6. So I've got 4 times ln, adding the logs, multiply them, so that comes to 18, adding the logs, multiply them so it comes to 6, but minus a log means that 18 over 6. So the final answer then is 4 ln 3 by inspection. Now, if you didn't like the inspection there because you didn't recognise it, and you had to evaluate the 1 to 2 of 8x over x squared plus 5 dx, then you would probably plump for a substitution, using the usual one, which is let u be the nasty. So that'll be that awkward denominator, in which case du by dx is going to be 2x. And whilst you're at it, may as well change those limits as well, rather than having to change that back again to reuse the old limits. So when x is 1, that means u is going to be 1 squared plus 5, which is 6. And when x is 2, that means that u is going to be 2 squared is 4 plus 5 is 9. No surprise, it's these same numbers down here. So this would then change into the integral from 6 to 9 of, and I'll leave the 8x alone, but dx is going to become du over 2x, maybe I should have put that down there, over just u, which is then, x cancels out, and that leaves 4, so it's 4 times integral from 6 to 9 of du over u, which of course is 4 times ln u evaluated from 6 to 9. So that'll just be 4 times ln 9 minus ln 6, which would then be 4 ln 9 upon 6. This part's just providing 4 ln 3 upon 2. But of course that's only part of the answer. Don't expect that to be the same as that, because that was only the second half done. You would, if you were doing that way, you'd have had to follow that through by itself and then add the two parts together. And that part would just be this portion here coming down, ln x evaluated from 1 to 2. So that's 4 times ln, and there it is, 2 minus 1. The other part would have been 4 times ln 2 minus ln 1, which of course is just 4 ln 2. And then putting those two together by adding them, you've got the common factor of 4, and then multiplying those 3 times 3 upon 2 times 2, which gives you the 4 ln 3 as before. But you're better off just recognising that you can do that by inspection the same way as you recognise that, and actually do that by inspection by saying that's just a log.